Does the microphone work? Can everyone hear me? Does it work?
I can hear you, but it needs to be louder. There you go.
Is that better?
Yes.
Okay. Even in the back, Michael? I think he's sleeping. Okay, wherever you go on the internet nowadays, you stumble upon a video that someone shares with their friends. It's a funny video, or other content that is shared. We saw that on YouTube, and we share internally videos a lot via the HTML macro. But if you want to do that on a public side, it's not possible to enable the HTML macro for security reasons. So we needed a different way to share YouTube videos and other widgets in Confluence. For this reason, we created the Widget Connector. The Widget Connector allows us to display widgets from all over the web, from a total of 30 different services in Confluence. For example, you can display YouTube videos, you can display a Flickr slideshow, Flickr pictures by tag, or slideshows or presentations that are shared on slideshare.com. We also support more than 100,000 widgets via Widgetbox, which is one of the biggest widget repositories on the internet. So how does it work? I'll give you a brief overview. I want to share an Earth Hour video. Earth Hour is a company or like an organization we worked with earlier this year. I want to share a video with my friends at Atlassian. So I used the widget, the macro browser to search for the widget connector. I picked the widget connector, and now I need the URL of that video I want to embed in Confluence. Simply copy the URL, paste it into the widget URL field, and can preview it right in the macro browser. It's not wide enough, so I make it a little wider, make it 500 pixels. I can refresh it again. That looks a little better. And then we go ahead and insert it in Confluence. Save it, and the picture will appear right there. So we can, in seconds, embed a video from YouTube or any other site in Confluence. So now there are many different services on the web, and we are unable to support every single one and to implement every single request we get in. So this is why we made it real easy for you guys to implement services or other widgets and support them yourself and embed them in Confluence. For example, last week Google released their web elements. Those web elements are different widgets. They're different tags. Some of them are iframes, some of them are embed tags. And they allow you to take a Google Calendar, a conversation, or a custom search, or even the spreadsheets, and put them in your blog or website. And Mike wanted them in Confluence as well, and asked me, can we do that in the Widget Connector as well? Can we embed them? So yeah, we can do. So how about I just do that at the conference next week at the summit and show the people how it's done. So how does it work? We've got, for the spreadsheets, we got an iframe. Since we can't copy that code straight into Confluence, because we don't have the HTML macro, we need to use this iframe tag as a template. This is what we do in the renderer for this service, for this widget. And the important part is those iframes, those templates, look the same for every single spreadsheet in Confluence, or in Google, for every single Google spreadsheet. The only difference is the identifier. In this case, it's the key, which is part of the URL, as you can see above, and it also repeated in the iframe web tag. So what we want to do with the widget connector, we simply create the iframe below from the URL at the top. And how that is done, I show you now in a plugin. That's better. Okay. We start off with the Maven configuration for the plugin. If you have written a Confluence plugin, then you know already how this POM looks like. There's some, is that running? Yeah. There's some configuration about the plugin key, about which version of Confluence you run against. And the important part for the widget connector, if you build your own service, is to have a dependency on a core widget connector plugin. In this case, we just depend on version 1.1, and we set the scope to provide it because it's already part of Confluence. The next file that is important is the Atlassian configuration itself. The plugin XML file describes the name and the components. Currently, we don't have any components, but we just go ahead and install the plugin into Confluence. to see whether it works at all and whether we got our setup correct. To do that, I'm using Maven and Don Brown. He's talking after me. He wrote a great CLI plugin that allows you to deploy a plugin into the local Confluence instance within like a few seconds. And you just saw it, it's already done here. We just install it. Now we go to the plugin administration, scroll down and see if the plugin is available in our Confluence instance. It's there. And as you can see, there are no components at the moment. So the next step we take is go ahead and go back to the plugin configuration and add the components. The first component we need is the velocity render service. This service is provided by the Widget Connector core. This is why we have to extend or depend on the Widget Connector plugin. And this service, we will use it later in the class. You will see what we do with this. And the second component we add is our Google Spreadsheet render. That's the render itself. We give it a key, we give it a name, and we can specify the class and the package name. We can also make it public so that other plugins can extend this render or can use this renderer in their plugins and rely on it and use the functionality. The important part here is that we extend the widget renderer interface. What this does is the normal Widget Connector plugin, the core plugin, has a list of all widget connectors, widget renderers that are in the system. And when we install a new plugin with a new widget renderer, this widget renderer or this class will be added to that list. So when we later run through the URL and we try to find a renderer for it, it will look at all renderers in that list and try to find the appropriate one. So the next step is that this is all we need to do here, and the next step is to actually go and implement the renderer itself. So this is the Google Spreadsheet renderer class. At the moment it's pretty empty, but that will change soon. So we created the class here and implementing the widget renderer. And the widget renderer has two methods we have to implement. The first one is matches, and the second one is get embed HTML. We come back to that method later and implement them later. First I want to create the constructor. So the important part to note for the instructor is that we pass the velocity render service, which we imported as a component early in the plugin file, in the plugin configuration. We pass it as a parameter to this constructor. This will inject the velocity render service into this class, and we can use it. And we can use it in this class later on. So we also want to specify some variables that will just make things easier and keep things clean. So the first thing we need is a regular expression pattern, because we want to take the URL and find the unique identifier from the URL so we can pass it to the template that we want to render. The second variable is the velocity template. In this case, we rely on an existing template that is part of the Widget Connector. The Widget Connector already has a template for embed tags or for iframes, for common embed methods. And if you look at the source, you can find them. We don't have it well documented. We hopefully change that soon, which templates are provided there and what variables you can pass in. So the iframe takes a few parameters, the width and the height. And the last parameter we specify here is the service URL. In this case, it's spreadsheet.com. Why this is important, you will see later. We're going to use that in the matches method now. So with the service URL, we want to see, first of all, we want to see which service matches our renderer. To do this, we simply check whether the URL that we pass in matches our service URL. So if the URL is spreadsheet.google.com/something, then it will try to render it with this renderer. And the second method we have to embed is the get embed HTML, or we have to implement is the get embed HTML. And what we do here is we do the whole parsing for the regular expression, and the second part is the actual rendering. So at the top here, we start off specifying the base URL of a spreadsheet. So it always starts with spreadsheets.google.com/pub. This is always how Google Spreadsheet URLs start. And then we pass out the unique identifier, the key, from the URL we have at the top with the regular expression. If we find a key, then we attach that to the base URL. And if we don't find the key, then we return null. In this case, the core widget connector will indicate that this service is currently not supported, or that the URL can't be found or can't be rendered. What we do here at the bottom is we pass in the width and the height parameters into the template. We also pass in the template parameters so that the velocity renderer knows what template is will be used by this service or by this render service. And the last thing we have to do is simply call the velocity render service. We call the render method and pass in the embed URL and the parameters. Then we go ahead and build the plugin. And then we reload this page for the plugin and see if the components appear. And here they are, they're green, which is good as well. We have the velocity render import, which we imported earlier, and the Google Spreadsheets renderer. And now we can create a page and see if that worked at all. So I'm going to call the page the Google Spreadsheet. And I use the macro browser to add that macro. The widget connector is still there. And all you have to provide then is the URL to this Google Spreadsheet you want to embed. And I ignore the width and the height for now, and just refresh it here, the preview. And here you can see it in the preview, and we just insert that and insert it into the page. Save the page. And it should just display here. And this is just what Google provides, the whole embed tag, and you can switch the views to a data view, and you can see what data has been entered, or you can choose to see the charts. And this was it for the demonstration. If you have any questions, please ask. Was that clear? Wonderful. I think then I hand it over to Don. Thank you very much.
Good evening. Wow. Let's move that down just a tad. Can you hear me okay? All right. I'll use my booming voice. Biz Stone, the co-creator of Twitter, once said that the Twitter API was the most important thing that he had done with Twitter. The remote API receives 10 times the amount of traffic that their pretty Web 2.0 website does, proving once again that no matter how fancy your website, people want to get at their data. And they want two things from a remote API. They want it to be comprehensive, and they want it to be easy to use. Now at Atlassian, we've done a pretty good job, I'd say, of providing a remote API with many of our products. However, our track record is a bit spotty on making it easy to use. This is how I see our products, ranked from hard to easy. Crowd and Jira, well, they're on a bit tough side with some SOAP and some weird uses of SOAP. Gets a little bit better with Confluence. Bamboo starts to use a simpler technology. Finally, we get down to Crucible and Fisheye, which use what we call a Restful interface. Simple URIs, XML payload, consistent interface, easy to use. And that's where we want to go at Atlassian. We want to go from here, WS Death Star, to here, RESTful Web Services. Great book, by the way. Anyone read this book? No one? Oh, that makes me sad. It's a good book. I don't even like to read books. Anyway, so REST. REST is an architectural style which is best implemented by HTTP. So for the purposes of our discussion here, let's define REST as the way of the web. It's about using the web the way it's meant to be used. Now, the four characteristics we're going to talk about. We're going to talk about how REST is about nouns, not verbs, in the URI. It's about standard HTTP methods. It's about multiple representations, separating the content from how it's represented. And it's about using links everywhere. Our data is meant to be connected, so let's display it that way. So what does that mean? Well, first, let's start with a resource with a uniform interface. This is the type of URL that you would see in many types of applications, and in fact, this is ripped straight from Confluence. What's happening here, when you invoke this URL with an HTTP GET, what you're doing is you're adding yourself on the server, you're adding yourself to the notification list for a space. So if someone modifies a page in that space, they send you an email. However, this is done completely wrong. There's 3 problems with this, which I've nicely highlighted in bold. First, we're using an HTTP GET, which is the exact opposite of what we should be using here. For one, this is modifying state on the server. GET is a read-only, cacheable request, and that's not what's happening. We're modifying stuff. We shouldn't be using a GET. Second, if you look at the URI, Uniform Resource Identifier, that means it's a thing. It is pointing at something. It is a noun. However, what we're doing here is we're mixing up the verb, adding, with the thing, which we're adding to the space notification. That is inconsistent. It's superfluous, because really the verb is already specified should be already specified up at the HTTP method. And then finally, the key down here, this is the key, the space key of the notifications list, which we want to modify. A key piece, identification piece of the information, of the identifier, however it's stuck into a query parameter. If we rewrote this URI more RESTful to follow HTTP, this is what it might look like. You notice it's simpler, it's clear, it's more obvious. First off, it's using a post. Post is for an action that does change the state on the server. It's for something that can't necessarily be repeated. You won't have the problems of proxies caching the response. The identification information is now part of the URI itself, and now the add space notifications has become a noun, a notifications resource. Once you make this URI more RESTful, you start to see the benefits of a uniform interface. And by uniform interface, I mean using the HTTP verbs get, post, put, delete. You start to see things like this. We can get the status of a notification. We can put or update the status of notification. We can delete a notification by simply using the HTTP verbs the way they're meant to be used and URIs to identify the resource, which is unchanged in these 4 operations. We now get a more consistent, more intuitive interface. So you see, HTTP methods operate as like traffic laws of the internet. Get, post, put, delete. They mean something. And unfortunately, to many of us web developers, we tend to just use post and get. And the only difference between, you talk to some people, the only difference between the 2 of them is get, when you request that the query parameters come over the URI. On a post, the URI is nice and clean. Well, the differences actually go much deeper than that. Get is something that should be done for read-only resources. It should not change the state on the server. Post should change the state on the server, and it's something that can't be done and again and again and again. Now, put and delete for updating and deletes, respectively, this is something that changes the state on the server, but can be repeated. If I delete foo, I delete foo, and then I delete foo, foo is still deleted. And finally, multiple representations. This is a really nice one for again, allowing your clients to access the data the way they want to. Let's say a URI. In this case, we have an orders down here. We want to see the state of this order in XML. Maybe one application is a Java app. It's got its nice mapping framework. It wants XML. Maybe we have a client-side JavaScript. It wants to see JSON. Or we have a human, and he wants to see HTML. The resource does not change. It is still a specific order. The identity is unchanged. However, the representation of that identity does change. We can do this in a number of ways. We can use the accepts header, the request header. We could use an extension. But the idea, again, separate the representation from the resource. So I could show you linking in more slides, but to be honest, I'm about to fall asleep. So let's switch over to an example. Hey, it works. Actually, that's the wrong example, though. This one. So this is a URI, a RESTful interface at plugins.atlassian.com. I'm sure you've seen the demo and the keynotes and whatnot. What we're looking at is it has a pretty nice RESTful API, and we're looking at the list of plugins that are available in plugins.atlassian.com. And as you can see, there's 307, a lot of them. Now, we want to see not 307 plugins. We want to see just one. And so instead of having to go back to our documentation, figure out how the hell to do that, we can simply follow the links. We're used to this in the HTML pages. There's no reason we shouldn't be using this in our web services. We can follow this link to find out more information about the AppLinks Confluence plugin. However, that one's boring, so I'm going to switch over to this one, the Community Bubbles plugin. Again, notice the hyperlinks down here. We want to find out information about the icon, maybe the URL. Again, we follow the hyperlink. We don't have to go back again to the documentation to figure out what that means. That helps decouple the service from the consumer. The consumer doesn't have to know all the different possible URI patterns. It just simply follows the links. It makes the API very self-discoverable and very user-friendly. So that's linking, and that's why it's useful. But let's do something a bit more interesting. If you've ever written a system, the first thing you're going to say is, that's not very efficient. Because let's say I want to get a plugin, and I want to get the URL to the icon for that plugin. Yes, I can follow the link, and I can do those 2 HTTP GET requests, but that's kind of shit when it comes to performance. We need to do something better. So there's a neat little feature that our REST APIs have, which is called Tidal Expansion. We ripped it off from Netflix. So if you notice down here, we want to get the icon, and the name of the icon of the element is icon. So when we do add the expand parameter, we not only get the information about the plugin, but we also get the information about the icon expanded in line. So when one request, I just requested multiple bits of information, saved myself a round trip, got some nice performance out of it. Now you can also do this for lists. You see down here we have 14 versions. Well, let's expand that version list a bit. And now we got all the 14 versions. Again, not very useful because we'd have to follow another link to find out information about the version. We can use the dot notation to traverse the tree. So now we're finding out versions, we're expanding that list, and we're also expanding the version information within that list. Now that's a lot of versions, 14. We don't really want to see all of them. We only want to see the first one. Using a bracket notation, we can only see the first one in the list. Or maybe we want to see the last one. Well, let's use the negative integer notation, and now we're seeing the last version in the list. You can also do ranges. So if we want to see the first 3 versions in the list, it goes like that. So that's saying I want to go from index 0 to index 2, and it displays them all nicely in line. And as you can see, I'm still using the dot notation for expanding out versions. So it's a nice little technique that we're using a lot to improve the performance of our REST APIs, but still not violate the central principle of REST, which is the identity and its resource. Again, another nice benefit is separating the representation of resource from the resource itself. Now, I had some more slides to talk more about the theory of REST. However, at this conference, I seem to be getting a lot of questions on how do I build RESTful services. So I thought I'd just include a very quick example. My original goal was to actually write this plugin in 5 minutes, but that might be a bit ambitious, so I'll just walk you through it quite briefly. How many of you are plugin authors? A few? How many of you actually want to write a REST service? Okay, good. This is for you. The rest of you, you get to be entertained by source code. The premier form. Okay, so what's happening here is we're using the REST module type. We're going to give it a key. Actually doesn't matter what we call it. We need to map it to a path. This is going to be his user API. This very simple plugin is responsible for exposing the list of administrators on a system. And then we give it a version. A nice feature of the REST plugin is you can version your REST services. So you can actually have multiple versions of your REST resources running at the same time. Now notice we're not pointing to any class. We're not pointing to any resource. Well, what's happening is the REST plugin is smart enough to scan the bytecode of your plugin and pull out the resources automatically. Here's an example of such a resource. This class user resource, as you can see, is a POJO, doesn't have to implement or extend anything, and it uses annotations to define how it should be used. We're mapping this to the user's path. This is what's going to happen if this resource is retrieved via GET. This is going to happen if it's retrieved via GET with some slash and information after it. Here's how it's deleted, and here's how it's posted. So as you can see, it's very minimal, the amount of work you have to do. You get to keep nice POJOs, a few annotations, and you get a RESTful service. You're returning back an XML user. Now, you might say, how do we serialize from XML and back to objects? Well, that's where this comes into play. Unfortunately, I don't have JAXB on here, so we get a lot of red. But what we're using is, again, another set of annotations on POJOs to define how this object is going to be represented as XML. A nice feature of the framework is we don't not only get XML, but we also get JSON. If we go back to our plugin here, and we use .json, you see the exact same information, but in a different form, one that's perhaps more friendly to client-side JavaScript. So that's how you write a plugin. It's not too hard. We're in the process of writing our own. If you're going to be writing gadgets, chances are you're going to need to be able to retrieve information from the server. The REST plugin is here to help. So the takeaway from all this, once Keynote starts back up, is first, check out the guidelines if you want to find out how we're building REST services at Atlassian. You want to find out how to use our services. The guidelines are useful. And finally, don't be afraid. Go build your own. Thanks. Right, so what's the timeline for exposing all of our applications' APIs as REST, was the question. And the answer is it varies, anywhere from pretty soon to I hope someday. In Bamboo, for example, I believe they're working on the remote API to actually rewrite it to use the REST. Crucible and Fisher are already RESTful. Jira and Confluence, it's certainly not in the official roadmap anytime soon. I hope it to be. I think for the near term, this is mostly going to be a tool for you to write REST APIs when you're writing gadgets and any type of integration. Yes, in the back.
What do you say to the proposition that once you add an annotation to something, it's not a POJO?
So Charles wants to know my philosophical thought on if you add annotation to a class, it's not a POJO. The answer is, I don't care. It just works. I'm pragmatic. Yes. Are the annotations required? I believe they are. It's part of the JAX-RS standard, and that's one of the nice things, is you're not tied to our specific REST module type. These are JAX-RS standards that are part of the J2E spec version 6, I believe. So it's, again, you're using pretty general stuff. There's a lot of tutorials out there on how to build these type of services. Yes?
Your last slide back on the screen and leave it there.
Yes. No, wherever the hell my mouse went, no problem. Anything else? All right, thanks.